Hello, we are here for one more lesson of this T-FLEX analysis training course. And the topic for today, still inside the forced oscillations, it is something that we call, it's an introductory information about this type of analysis. So this forced oscillations module of this system, which you know already, it's a finite element modeling, call it T-FLEX analysis. Can be used for analysis of steady-state forced oscillation of several types. These several types include three main types. First one, it is a forced oscillation of the system without damping, subjected to harmonic driving loads. There are a couple of equations and variables that you can check a little more in our theoretical course, but a description of this first type it is done. A second type, it is what we call a forced oscillation of the system with damping subjected to harmonic driving load. The first one was without damping. This is with damping. And again, we have a couple of differential equations that can be found in the theoretical side. And third and last type, it's a forced oscillation of the system of two indicated types that are caused by harmonic motion of foundations. An example, it's the initiation of oscillation motion of one or several supports of the system. Again, we have a couple of formulas or equations that you can read a little more about it. It is important also when we take into account these systems that when we analyze the forced oscillation, it is important to take into account the influence of damping forces. We've already mentioned it. An explanation of what is damping or definition. Damping, it's called a process of energy dissipation of these mechanical oscillations resulting in a gradual decay of systems oscillations once they are initiated. These damping forces can have different origins. For example, the friction between dry surfaces with sliding. The friction between lubricated surfaces can also originate these oscillations. Internal friction, air or water resistance, and others. These are some examples. Usually we assume that this damping force is proportional to the velocity. This is what we call the viscous damping. And resistant forces that change in an arbitrary way are replaced by equivalent damping forces based on the condition that during one cycle they dissipate the same amount of energy as the real forces. These are some explanations about what is damping, and you can read a little more about it again in our theoretical course. Finally, in terms of this introductory information, the results of the analysis of this forced oscillation module includes the following quantities. The displacement amplitudes in nodes of the finite element mesh, and finally the oscillation overloads defined as a ratio of the oscillation acceleration to the gravitational acceleration. There are again a couple of additional informations in our theoretical side. This is a little more theoretical, but these are important notions also for understanding a little better what you are doing and what T-FLEX in fact deals with and how we calculate this type of studies. So any additional help, any clarification, or something that we may said and it is incomplete or you did not understood, let us know, and we will give you all the necessary explanations. But again, please see our theoretical side. We have now already available a reserved area where you can see more information, more documentation about these topics and other topics for other softwares.